Hi, Mr. Troha. This is my reassessment for IMM.1 and 2. I've already started because I've actually tried to make this video like 3 times and I'm not good at making videos, but hopefully this one will work. So I hope it's okay that I'm not redoing this problem again. So I'm just going to walk you through what I've done already. I am using a problem that we did on a previous assessment that I have done like no work on just because I hadn't learned at the time we took the assessment, and I haven't worked on it since. So this is the very first time I've done this problem. It's for IMM1. It's the one on a assessment from a long time ago. I don't have a date on here, but so it's this one, which you can't really see. I'm sorry. But anyway, the problem I'm doing is the clown on the back. So I'll just walk you through what I've done so far, and I'm hoping that's okay. So I wrote down a general equation for this unit, which is velocity initial times mass 1 plus mass 2 is equal to final velocity times mass 1 plus mass 2 plus mass 3, and etc., etc. So it was kind of confusing the way this problem was worded, so I kind of did like my own little like outline of how it goes exactly. So there are 2 stages to this problem where clown B throws the ball into the air, and the final velocity in that stage is 0 because it starts out in his hand, and the final velocity where basically this stage 1 ends, the ball is in the air, and the problem tells me that it's going at 10 meters per second. The second stage is where clown B throws it all the way to clown A. That's the way I'm understanding it anyway. So the initial velocity in that is beginning where stage 1 left off, so the initial velocity is 10 meters per second, and the final velocity is going to be 0 because clown A catches it. Okay. So the first part of the problem says it asks me what the resulting velocity of clown B after throwing the ball is. So basically it's asking me for the final velocity of clown B. So I started by writing down our equation, and then I plugged in values for it. Yeah, and so I got the values the problem gave me. I drew like a little stick figure thing up here just because that was easier for me than glancing all the way back. So the change of position is 2 meters. Clown A weighs 70 kilograms, clown B weighs 50. The medicine ball thing that they were tossing is 5.0 kilograms, and it's going at 10 meters per second. Yeah, so, and then I also wrote that positive is going this way and negative is going that way. Just because the second part of problem A is asking me to indicate which direction is positive, so that's just a reminder for me. So here's where I sort of already messed up a little bit, but I fixed it, so hopefully that's okay. So I wrote down my general equation, and then I started to plug in values, and so I actually put the values in the wrong order, and so that's why over here I wrote down which value was which. So sorry to change it around there. So anyway, back to solving. So the initial velocity of stage 1, this is where the problem that I'm being asked is concerning with stage 1, as far as I can tell. So the initial velocity is 0. Our mass 1 value is 50. Our mass 2 value is 5. It's equal to our final velocity, which this is our variable that we're trying to solve for. Mass 1 is again 50. Our final velocity of the second stage is 10, because the final velocity of stage 1 is what I'm trying to say. So yeah, and then our mass 2 is 5. So here's where I will continue on from where I left off in my last video, which unfortunately you didn't see because it was kind of, yeah, I got interrupted. Anyway, so I'm going to solve this. This is multiplied by 0, so it cancels out completely. So 0 is equal to our final velocity, which is our like x value basically, times 50, plus 10 times 5, which is 50. I don't really know why I'm talking, you know how to solve math. Anyway, so subtracting 50, this is now negative 50 is equal to final velocity times 50, and let's just divide that to get our value. So our final velocity for stage 1, also known as the resulting velocity of clown B after throwing, is -1 meters per second. Yeah, units. So so that's, and also it is negative because it's going in the direction away from clown A, as shown by my little stick figure drawing up here. So yeah, it's going that way. So awesome. Anyway, so part B, this part I'm going to continue on Part B is, what is the resulting velocity of clown A after catching the ball? Whew, okay, so this part I haven't done any work on. I mean, I haven't done any of the work on the other part either, but anyway. So, I'm going to start by writing out my values because that's where I screwed up previously. My mass 1, so it's asking about clown A now, so it's now 70 kilograms instead of 50 because the weights are different. My mass 2 is still 5 because that's still how much the ball weighs, hasn't changed. Our initial velocity, resulting velocity after clown A, okay, our initial velocity, so this is now stage 2, I guess, which will help me in my thinking, I think. Initial velocity is, yeah, it's 0 for the first part, but in this case I think I'm going to go with 10. But I will still use 0 in the first part of the equation. So I'll write that, I guess, initial velocity 2, initial velocity units. We're solving for our final velocity 2. I guess that should be a question mark, not a 0. And our final velocity for the first part is going to be 0 at that point. Okay, so now for plugging in the equation. So our equation is still V, sorry, it's hard to see, I'm not good at making videos, plus V, oh, that's equal, this is equal, whoops, M1, M2, okay, so, this is 2. So now we're going to plug in our values. This is still 0, mass 1 we decided was 70, plus mass 2, which is still 5.